All right, Math 110, we are now starting in Chapter 5, which is discrete probability distributions. The word discrete just means countable. And so this means we have a countable number of values. And 5.1 is a probability distribution. A random variable, which we're going to go ahead and star, is a variable typically represented by an x that has a single number value determined by chance for each outcome of the procedure. So we have an example here. It says, suppose you flip a fair coin twice. And the outcomes are going to be heads, 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 tails, tails, heads, and tails, tails. If the random variable x represents the number of heads in the two flips of the coin, so you can look up here, then all the possible values of x are 0. There's either 0 heads, in this case, 1 heads, or you could have 2. The uppercase x is identifying the random variable, and the lowercase lists all the possible values. So definitely something that we should know. We have what's called a discrete random variable and a continuous random variable, which goes along with what we learned back in Chapter 1. It says a discrete has either a finite or countable number of values. The values of a discrete random variable can be plotted on a number line with spaces between each point. Whereas we have a continuous random variable, this is if it has infinitely many values. The values of a continuous random variable can be plotted on a line in an uninterrupted fashion. So example down here says determine whether the random variable is discrete or continuous. So go ahead and pause the video and try that. Okay, so the weight of a steak, again, it's a weight, which is a measurement, is continuous. We have the number of light bulbs that burn out the next week in a room with 20 bulbs. This is definitely discrete. You can count those. Amount of rain in Seattle in April. Again, we're measuring something, so this is continuous. And then time required to download a file from the internet, which is also something that's measurable. We measure time, so this is continuous also. Next thing we have is a probability distribution. Go ahead and give that a star. So a probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. So this is going to be the possible values for the variable and the probabilities. It can be formed as a table, a graph, or a mathematical formula. Next thing that we have is the probability distribution requirements. And it says every probability distribution must satisfy each of the following 3 requirements. And so it says the first thing is there's a numerical random variable. So this has to be a numerical random variable. So not categorical. And we have that the sum of the probabilities has to equal 1. And then we have that all the probabilities have to be between 0 and 1. And again, including 0 or including 1. So the next thing that we have on here, the example says determine whether each of the distributions is a discrete probability distribution. If not, state why. So first thing, x that we have on here is a numerical random variable. I'm going to go ahead and put RV for random variable. So it takes on 100, 200, and so forth, those values. That is numerical. If you were to add up all of your probabilities, which is what the sigma means, so if you add these all up, you should get 1. And when you add up these values, check it on your calculator, but we get 1.25, which is not equal to 1. Since this is not equal to 1, we can say this is not a discrete probability distribution. So go ahead and try B on your own and check the posted notes to see if you got it correct. Next thing we have is going to be a probability histogram. Horizontal axis equals the value of the random variable, and the vertical is going to represent the probabilities of each value of the random variable. So again, we have on the vertical and on the horizontal, we have two different things going on. Vertical represents the probabilities. And on the horizontal, we are going to have each value for the random variable. Okay, page 2. There is an example up here at the top. And hiring managers were asked to identify the biggest mistakes in the job applicants make during the interview. Does the table below represent a probability distribution? If so, create a probability histogram. So does this represent? First thing is not met. This value, x, has to be numerical. And if you see, these are not numbers that we're dealing with here. So this is not numerical. Random variable. So we can say that this is not a probability distribution. So not a probability distribution. So with the probability distribution, we have a description of a population instead of a sample. So the values of the mean, standard deviation, and variance are all parameters, not statistics. So I'm going to go ahead and give the mean a star here. We use mu for our probability distribution. It's the sum of x times p of x, where x is the value of the random variable and p of x is the probability. And so you're going to multiply those all together for each value, sum them up, and that would be your mean. We have the variance and the standard deviation, which I'm not going to stress too much about. And then we have rounding the mean, the variance, and standard deviation. Again, this is what I talked to you guys about with the book. Expected value is our new one here. So the expected value is the mean value in the long run for many repeated samples of the probability weighted average for all the possible values. And if you notice, we have e of x here, but it is just equal to the mean that we had up above. So from here, we will pick up some good examples